My dear students, let us revise something that we have studied in the last period, that when the atom, or that is what we have studied about the structure of the atom. Let us have a look to it. Uh, okay, let me explain here what we have studied into the last period. We have studied that the atom is not indivisible, but atom is divisible. Atom has three subatomic particles, three subatomic particles. We have seen that one of them is known as proton, we represent it as a P plus. Another one is electron, we represent it as a E minus. And neutron. Proton has got positive charge, electron has got negative charge, and neutron has no charge. The mass of electron is negligible, but the mass of proton is almost 2000 times the mass of electron, and the mass of neutron is greater than the mass of proton. But the mass of neutron and mass of protons are very similar or very near to each other. We have even seen, my dear students, that the, the atom has got a center. The atom has got a center. This center is known as a nucleus. This is what it is known as, a nucleus. In this nucleus, we get either proton or we get neutrons. Electrons revolve around the nucleus in a path. These electrons can be found out here. We have seen that in the first, suppose this is the nucleus, then this is the first, this is the second, this is the third, this is the fourth, this is the fifth. So we can give them the names, like for example, this is n is equal to 1. This is what we call it as a n is equal to 1. This is what we call it as a n is equal to 2. This is what we call it as a n is equal to 3. This is what we call it as a n is equal to 4. And then on the base of these numbers, we have given them the alphabets, like n is equal to 1 is called K shell, n is equal to 2 is called L shell, n is equal to 3 is called M shell, n is equal to 4 is called N shell. So same way, my dear students, we give them the various names. Now, my dear students, we need to understand how the electrons can be filled into them. So to understand how the electrons can be filled, let us try to see and let us understand it well. When we want to fill the electron into the shells, we need to remember that we can fill maximum 8 electrons. So the first thing that we need to know is maximum 8 electrons can be filled in a shell. But when it comes to the shell number 1, that is K shell, the number of maximum electrons that can be filled is represented by 2n square. For K shell, we have n is equal to 1, and that is why the maximum number of electrons that we can fill is 2 into 1 square, that is 2. Same way, if you look into L shell, then you have n is equal to 2, and that is why 2 into 2 square, that is 4. That is 4, that is 8. So 4, this is 4 multiplied by 2 gives us 8. So this is how, my dear students, we understand how the electrons are filled. You just need to remember that your K shell can have maximum 2 electrons. So we can fill only 2 electrons into the K shell. Then the next shell we can fill 8. Even after that we can fill 8. But in K we can fill only 2. Now one more thing, my dear students, that this number of electron does not are not important for us for determining the atomic mass or atomic number. We have two things. One is atomic mass. This, sorry, my dear students, this atomic mass is represented by A. We have atomic number that is represented by Z. Now we have protons in the nucleus or center, and we have neutrons in the nucleus. So this Z is determined by the number of protons. So your Z is equal to number of protons, and your A is equal to both the numbers. So your A is equal to the number of protons plus number of neutrons. My dear students, please remember that your A, that is atomic mass, is equal to number of protons plus number of neutrons. Number of electrons are not utilized to determine whether the atomic mass or atomic number. So we will be depending on the number of protons and number of neutrons to determine the atomic mass or atomic number. Now we want to study about the first 20 elements and their structure in their atoms. So we have started with the hydrogen atom. Yesterday actually we have discussed, but I would like to discuss it with you once again. So now you can see on your screen the structure of hydrogen atom. This hydrogen atom has got one proton and zero neutron. Please remember that hydrogen atom does not have any neutron, and it has got one electron which is filled into the K shell. So we can represent the electronic configuration of hydrogen as hydrogen is equal to, or electronic configuration of hydrogen is 1. Now we want to determine the atomic number or atomic mass number for the hydrogen. To determine the atomic number or atomic mass number for the hydrogen, my dear students, we write here the representation of the hydrogen. When we write the representation of the element, any element, in the subscript, in the lower side, we write Z, which is known as the atomic number. This is what it is, Z, my dear students. And this Z represents the atomic number. On the upper side, we write A, which is the atomic mass number. And here we write this symbol of the element. So my dear students, you can see that I have written the symbol of element hydrogen, which is H. You can see that the number of proton is 1, so your Z is equal to 1, and number of protons plus number of neutron is equal to 1 plus 0, but 1 plus 0 is also 1, and that is why I have represented hydrogen as 1H1, and its electronic configuration is 1. Now let's go and understand the second element. The name of the second element is helium, that you can see on your screen, my dear students. So my dear students, when you have the name of the second element, which is helium, you can easily understand that in helium you can see that we have two proton and we have two neutrons, and there are two electrons revolving around the nucleus. So for helium, as we have two electron, both the two electrons are filled into the K shell, and that is why the electronic configuration of helium is 2. So when we write the electronic configuration of helium, we write 2 in front of it. It has L shell and M shell, but they do not have any electron, and they have 0 electron in them. Now, my dear students, we want to study about the atomic number and atomic mass number for helium. We determine atomic number Z and we determine atomic mass number A. How do we determine Z and A? So we determine Z from the number of protons. You can see that here the number of proton is 2. So Z is equal to 2, that is what we have written. Now how do we determine the A? A is known as the atomic mass number, and we know that A is equal to number of protons plus number of neutrons. So what is the number of proton? Number of proton is equal to 2, and number of neutron is also equal to 2. You can see it here. And that is why instead of A you write 2 plus 2. But your 2 plus 2 is equal to 4, and that is why your A is equal to 4, your Z is equal to 2, and you write the symbol 2He4 for the new element helium. Now, my dear students, we want to study about the third element, which is known as the lithium. So the third element of the out of the first 20 element is lithium. Let us study about lithium, my dear students. So when we look at the lithium, or when we look at the structure of atom of the lithium, lithium has got 4 nitrogen and 3 proton in the nucleus. This is the nucleus of lithium. Now in the first shell, if you look at, you will come to know that it has one orbital, that is the K shell of the lithium, and it has got 2 electrons. So you can see that I have represented 2 electron into the K shell of the lithium. So this is our lithium, and you can see there are 2 electrons in the lithium for this particular reaction. This is what we are talking about lithium. So for lithium, we have 2 electrons in the K shell and 1 electron in the L shell, because K shell has been completely filled with 2 electrons, and thus the third electron goes into the L shell. Remember, my dear students, that atom is electrically neutral, and that is why it has same number of protons and electrons. So as it has 3 proton, it has 3 electrons. So the electronic configuration for lithium, my dear students, we can write the electronic configuration of lithium in that is 2, 1. That means it has 2 electron in K shell and 1 electron in L shell. Now we want to determine the atomic number and atomic mass number. Atomic number Z is determined from the number of protons. Please remember that atomic number Z is determined from the number of protons. So in place of Z we have written 3. Atomic mass number A is determined from the number of protons plus number of neutrons. So if you determine A, your A is equal to number of protons plus number of neutrons. Here you can see that the number of proton is 3, so we have written 3, but the number of neutron is 4, so we have written 4. And here we write the symbol of the element, that is lithium. So we can write 3 lithium 3 plus 4. Instead of writing 3 lithium 3 plus 4, we write 3 lithium 7. This is the symbolic representation of our third element, lithium, and this is how we understand the structure of lithium. Now, my dear students, we want to study about the fourth element. So the fourth element is having the name beryllium. So you can see here, my dear students, the fourth element, which is beryllium, that we can see here. Now let us study about the structure, or let us study the structure of the beryllium. When we look at the beryllium, my dear students, we come to know that beryllium has got, or we realize that beryllium has got 4 proton, because its atomic number is 4. It falls into the fourth number, and that is why it has got 4 proton. As it has got 4 proton, my dear students, beryllium has also got 4 neutrons simultaneously, 4 electrons simultaneously. So we are trying to study about the beryllium now. Here this is the beryllium, and in this beryllium you can see that we have 4 proton, and that is why the atomic number is 4. It has got 4 electron. These 4 electrons are filled in such a way that in K shell we have 2 electrons, and in N shell we have 2 electrons. So these are the 1 and 2 electron in K shell, and these 2 electrons are present into the L shell. So we can write the electronic configuration of beryllium as 2, 2. Now, my dear students, we have the another part to understand, that the number of, or the atomic number is represented by the number of protons, and that is 4. So Z is equal to 4, and atomic mass number A is equal to N plus P. So number of protons plus number of neutrons. Number of proton is 4 and number of neutron is 5. 5 plus 4, that becomes 9, and that is how we represent our beryllium as 4 beryllium 9, or 4 Be9. Now, my dear students, let us understand the next element, and the name of the next element is boron. So let's pay attention to the boron. You can see here, this is the structure and discussion for our boron. You can see that boron falls in the fifth number, and that is why it has five protons. As boron is on the fifth number, it has five electrons, and out of those five electrons of boron, my dear students, we realize that the first two electron goes into the K shell. You can see this is the first and second electron, and then the other three electrons go into the L shell. And that is why we can write the electronic configuration of beryllium as 2, 3. Now, my dear students, we want to understand about the atomic number of boron, sorry. So, atomic number is determined by the number of protons, and you can see that here we have 5 protons, and that is why in the subscript we write 5, 5b. Now, we want to study about the atomic mass number, that is the atomic mass number here is actually uh, the number of protons plus number of neutrons, that is a is equal to p plus n. You can see that here the number of proton is 5, the number of neutron is 6, and that is 5 plus 6. My dear students, this 5 plus 6 totally gives us 11, and that is why the atomic mass number is 11. And this is how we represent 5 boron 11. So, my dear students, this is the way of representing the boron. Now, my dear students, we want to study about carbon. When we look at the carbon, we realize that in carbon falls on the sixth number. So, carbon has got 6 proton and 6 neutron. At the same time, carbon has got 2 plus 4, 6 electrons present or revolving around the nucleus. So if we write the symbol of carbon, and if we want to write the electronic configuration of carbon, we would write C 2, 4. What is the meaning of 2, 4? The meaning is that there are 2 electrons in the K shell, you can see here 1 and 2, and there are 4 electrons in the L shell. You can see that 1, 2, 3 and 4 electrons are present in the L shell. So this is how we understand the electronic configuration of carbon. Now we want to study about the atomic number and atomic mass number. The atomic number is Z, that is determined by the number of protons. You can see that here we have the number of proton is equal to 6. So for subscript we write 6. Now we want to study about the superscript, which is your atomic mass number. Atomic mass number A is equal to number of neutrons plus number of protons. Here you can see that the number of neutron is 6, the number of proton is even 6. So we have written 6 plus 6. We know that 6 plus 6 gives us 12, and that is why, my dear students, we write carbon as a 6C12. 6C12. It represents that the atomic number of carbon is 6, but the atomic mass number of carbon is 12. Now we want to study the next element, and the next element is our nitrogen. So you can see here we have nitrogen here. Now, my dear students, if you look at the nitrogen, you can see that nitrogen has got 7 proton and 7 neutrons. And that is why the atomic number Z for our nitrogen is 7. Now, when we look at the electronic configuration of nitrogen, you can see that there are 2 electrons present into the K shell, 1 and 2. Whereas in the L shell, we have 5 electrons. Let us count 1, 2, 3, 4 and 5. So we have 5 electrons present into the nitrogen, and that is why when we write the electronic configuration of nitrogen, we write it as a 2, 5. What does it mean? That in K shell nitrogen has got 2 electrons, and in N shell nitrogen has got 5 electrons. Now, my dear students, we want to study about the atomic number and atomic mass number. Atomic number Z is directly or is determined by the number of proton, and number of proton here it's 7, and that is why we write Z is equal to 7. Z is equal to 7 for our nitrogen. Now the atomic mass A is determined by the number of neutrons plus number of protons. Here you can see that we have 7 neutrons and 7 protons. So we can write 7 plus 7 or we have even written this 7 plus 7 over here. You can see that. So for nitrogen, we write 7 plus 7. 7 plus 7 is nothing but 14, and this is how we represent our nitrogen as 7 and 14, where we write subscript, that is your atomic number Z, and the superscript, that is your atomic mass number A, my dear students. Now let's move and study the structure of oxygen for our discussion. So you can see the picture of oxygen in front of your or on your screen, my dear students. This is what we are studying about the new structure of atom, that is oxygen. Oxygen has got 8 proton and 8 electron, and you can see that total 1, 2, 3, 4, 5, 6, 7, 8 electrons are revolving around the nucleus. Out of these 8 electrons, my dear students, you can see that the 2 electrons are present into the K shell, whereas the other 6, 1, 2, 3, 4, 5 and 6, the other 6 electrons are present into the L shell. This is how, my dear students, we write the electronic configuration of oxygen, that oxygen is equal to 2, 6. What is the meaning of 2, 6? It represents that in oxygen, 2 electrons are present in K shell, whereas 6 electrons are present in L shell. Now we determine the atomic mass number and atomic number. Atomic number is determined by the number of protons. So the atomic number for oxygen is 8, and atomic mass number for oxygen is the number of protons plus number of neutrons. Number of proton is 8, number of neutron is 8, and that is why 8 plus 8 gives us 16, and that is why we represent oxygen as 8O16. 8O16 means the atomic number of oxygen is 8, whereas the atomic mass number of oxygen is 16, my dear students. Now, dear students, we want to study the ninth element, and the name of the ninth element is fluorine. So here on your screen, my dear students, you can see here on your screen, my dear students, you can see the structure of the atom. You can see the structure of the atom of our fluorine atom. So this is your fluorine atom, my dear students, and here we study about the fluorine atom. In fluorine atom, if you look at, you have 9 proton and 9 electron revolving around the nucleus. Out of those 9 electron, my dear students, you can see that 2 electrons are there in the 2 electrons are there in the K shell. You can see that these are the 2 electrons available into the K shell. Dear students, can you see the screen on your screen?
Yes, sir.
Okay.
Yes,
So
sir.
here you can see that, my dear students, that we have 9 proton present into the nucleus, and that is why we have 9 electron, and out of those 9 electron, the first 2 electrons are present into the K shell. So you can see that these 2 electrons present into the K shell, 1 and 2. Then in the L shell, we have 7 electrons. Let us count 1, 2, 3, 4, 5, 6 and 7. So we have 7 electrons present into the L shell, and that is why we write fluorine electronic configuration is 2, 7. What is the meaning of writing 2, 7? That in K shell we have 2 electrons and in L shell we have 7 electrons. Now we are going to study about the determination of the atomic number and atomic mass number. We know that atomic number Z is represented by the number of protons. So here you can see that the number of proton is 9, and that is why the atomic number of fluorine is 9. So here we have written 9F. 9 is written as a subscript. Now we want to determine the atomic mass number A. Atomic mass number A is equal to number of neutrons plus number of protons. So here you can see that we have number of proton is 9. So we have written 9. We can even write 9 here. And sorry, number of proton is 9. And number of neutron here in the fluorine we have 10. So total it becomes 19. So my dear students, you can see that in the fluorine we have 9 proton and 10 neutron. So atomic mass number become 19, atomic number become 9, and this is how we represent 9F19. 9F19 says that the atomic number of fluorine is 9 and atomic mass number of fluorine is 19. Now, my dear students, we want to study about the new element, and the name of this new element is neon, which falls or which is the 10th number element. In neon, my dear students, we have 10 proton and 10 neutron. And of course, as we have 10 proton, 10 electrons revolve around the nucleus. In case of the neon, my dear students, if we look into the electronic configuration or the electron distribution, you can see that in the K shell we have 2 electron 1 and 2. But in the L shell we have 8 electrons 1, 2, 3, 4, 5, 6, 7 and 8 electrons are present into the neon shell. Thus we can write the electronic configuration of neon as 2 comma 8. What is the meaning of 2 comma 8? That in the K shell of neon we have 2 electron, and in the L shell of neon we have 8 electron. We are well aware that in any shell or in any orbital we can fill maximum 2 electrons, and thus the limitation of this is over, and we can fill this much of maximum electron in the next in this shell. So now if we move or if we want to add the electron, that particular electron has to be added into the next shell, my dear students. Now we want to determine the number, atomic number and atomic mass number. So we know that the atomic number is determined by the number of protons, and we know that here we have 10 protons. So in the subscript we have written 10. We know that the atomic mass number A is determined by the number of protons and number of neutrons. Here you can see that the number of neutron is 10, the number of proton is also 10, and that is why for atomic mass number A we write 10 plus 10. 10 plus 10 is equal to 20, and thus we can write neon, or we can write the symbol of neon as 10 Ne20. It represents that neon has got atomic number 10 and atomic mass number 20, my dear students. Now we want to study about the next element, and the name of the next element is our sodium. So let us study about the 11th element, sodium. Here in the 11th element, sodium, you can see that sodium has got 11 proton and 12 neutron. Out of this 11 proton and 12 neutron, we will determine the atomic number and atomic mass number. Let us first study about the electronic configuration. So if we write Na for sodium, we can see that in the first K shell, we have 2 electrons. So we have written K in the box of K. We have written 2 in the box of K. Now if we look at the next shell, we have 1, 2, 3, 4, 5, 6, 7 and 8 electrons into the L shell. So we have written 8 in the box of L. But now, my dear students, the next electron, which is the 11th electron, goes into the M shell, and you can see that here we have the next electron which is going into the M shell, and thus we can write the electronic configuration for sodium is 2, 8, 1. This is what it is known as the electronic configuration of sodium. So that means that in sodium, 2 electrons are in K shell, 8 electrons are in L shell, and 1 electron is present in M shell. Now let us determine the atomic number and atomic mass number for sodium. Atomic number Z is determined by the number of protons, and you can see that sodium has got 11 proton, and that is why the atomic number of sodium is 11. Atomic mass number A is equal to number of neutrons plus number of protons. As we have the number of neutron is equal to 12, so let us write 12. Number of proton is equal to 11, so let us write 11. That we have written here also, 11 plus 12. That is what it gives us the answer 23. So your atomic mass number A is equal to 23 for sodium. So thus we can represent sodium as 11Na23, and my dear students, this 11Na23 represent, or it says that the number of or the atomic number of sodium is 11, whereas the atomic mass number of sodium is 23. Now, my dear students, we want to study about the 12th element, and the name of this element is magnesium. So let us study about the magnesium. Here you can see that in magnesium we have 12 proton and 12 neutron. So as we have 12 proton, atom being electrically neutral, we need 12 electrons. Out of those 12 electron, my dear students, you can see that in the first shell K we have 2 electron 1 and 2. In the next shell L, we have 8 electron, 1, 2, 3, 4, 5, 6, 7, and 8. But in the next or next to next M shell, my dear students, we can see that we have 2 electrons filled in it. So this is electron number 1 and electron number 2. So thus in magnesium, out of 12 electron, the 2 electron are in K shell, 8 electron are in L shell, and 2 electrons are in M shell. Thus, my dear students, the electronic configuration for Mg, we can write it as 2 comma 8 comma 2. This 2 comma 8 comma 2 represents that the 2 electrons are present in K shell, 8 electrons are present in L shell, and 2 electrons are present in M shell for magnesium. Again, my dear students, the atomic number is determined by the number of protons. So atomic number of magnesium is 12. Atomic mass number is determined by the number of protons plus number of neutrons. Number of proton is 12. Number of neutron is 12. Total 24. And thus the atomic mass number of magnesium is 24. And ultimately we represent magnesium as 12 Mg24, which says that the atomic number of magnesium is 12 and atomic mass number of magnesium is 24. Now dear students, let's study about the 13th element, and the name of the element is aluminium. So here you can see the aluminium and its structure I have drawn for you. Aluminium falls on the 13th number, and thus it has got 13 proton and 13 electron. Out of 13 electron, my dear students, we can see that in aluminium 2 electrons goes into the K shell. So you can see 1 and 2 electron in K shell, 1, 2, 3, 4, 5, 6, 7, and 8 electron in the L shell, and then 1, 2, and 3 electrons in the M shell. So thus, my dear students, we can understand that the electronic configuration of aluminium is the electronic configuration of aluminium is 2, 8, 3. So this is how we understand the electronic configuration of aluminium, my dear students. And it represents that aluminium has got 2 electron in K shell, 8 electron in L shell, and 3 electron in M shell. Now if we determine the atomic number of aluminium is equal to the number of protons present into the aluminium, and thus the number of proton in aluminium is 13, and that is why the atomic number of aluminium is 13. Atomic mass number is determined by the number of protons plus number of neutrons. Number of proton is 13 and number of neutron is 14. 13 plus 14, that gives us 27, and that is why the atomic mass number of aluminium is 27. And thus, my dear students, we represent aluminium as 13 aluminium 27, which represents that aluminium has got atomic number 13 and atomic mass number of aluminium is 27. Now let's look and study the next element, and the name of the next element is silicon. So here you can study about the silicon, my dear students. In silicon you can see that there are 14 protons, and as there are 14 protons, we have 14 electrons. You can sum this: 2 plus 8, 10 plus 4, 14. So in silicon, my dear students, 2 electrons are present in K shell, 8 electrons are present in L shell, and 4 electrons, you can see 1, 2, 3, and 4 electrons are present into the M shell. Thus the electronic configuration for silicon, which is having atomic number 14, atomic number 14 is nothing but 284. So this is how, my dear students, you represent the electronic configuration for silicon. Now if we determine the atomic number and atomic mass number, we can easily understand that atomic number is determined by the number of protons, and thus silicon has got 14 protons, and thus the atomic number of silicon is 14. Atomic mass number is determined by the number of proton plus number of neutrons. So number of proton is 14, number of neutron is even 14, and thus 14 plus 14, that gives us 28, and thus we can say that the atomic mass of silicon is 28. Thus by the representation, we represent 14 Si28. It says that the atomic number of silicon is 14 and atomic mass number of silicon is is 28, my dear students. Now we want to study about the another element or the next element. The name of this element is phosphorus. We represent it with the symbol P. In phosphorus, we have 15 proton and 16 neutron, and thus we have 15 electrons. You can see that in phosphorus, in K shell, we have 2 electrons. In L shell, we have 8 electrons and 5 electrons. 1, 2, 3, 4 and 5 electrons are present into the M shell. Thus, we can represent this electronic configuration of phosphorus as 2, 8, 5. What does it represent? This 2, 8, 5 tells us that we have uh, 2 electron in K shell, we have 8 electrons in L shell, and we have 5 electrons in M shell for the phosphorus. Now, my dear students, we want to determine the number of now we want to determine the number, atomic number and atomic mass number. So if we look into the electronic configuration, we will uh, we will realize, my dear students, that in this particular case, in case of the phosphorus, बच्चों आपको screen दिख रही है? Can you see the screen, dear students? Hello?
Yes, sir.
Okay, so you can see that we have 15 number of protons, and that is why the atomic number of phosphorus is 15. Atomic mass number is determined by the number of protons plus number of neutrons. As the number of protons and number of neutrons here, if we calculate them, then the number of proton is 15 and number of neutron is 16, and 15 plus 16, that gives us 31, and thus the atomic mass number of phosphorus is 31, and thus we represent phosphorus as 15p31, which says that the atomic number of phosphorus is 15 and atomic mass number of phosphorus is 31. So my dear students, let us stop the class today, and the rest of the element we will study into the next class. अगर आपको कुछ doubt है, if you cannot understand anything, if you want to ask something, you can ask. बच्चों अगर कुछ समझ में नहीं आया और आपको कुछ पूछना है तो आप पूछ सकते हैं. कुछ पूछना है बच्चों? क्या आप मुझे सुन पा रहे हो?
Yes, sir.
आपको कुछ पूछना है तो पूछिए. Okay, then, thank you. Have a nice day.